Hi guys, today we're also doing destination city. So we're given the array paths where paths at I equals city A, city B, like an array of size 2 basically, which has a direct path going from city A to city B. And they want us to return the destination city, which is the city without any path out going to another city. And it's guaranteed that the graph of paths forms a line without any loop, so there will be exactly one destination city. So we don't need to worry about edge cases or anything like that. So I think it'll make more sense if we look at the examples. So in example 1, we have paths equals this array, and we output Sao Paulo because starting at London, we will reach Sao Paulo, which is the destination city. So we start from London, and then we go from London to New York, and then from New York to Lima, and then from Lima to Sao Paulo, and that's our last city. And then in example 2, so we have paths equals this array, and no matter where we start, so we output A, but like no matter where we start, we're gonna end up at A. So like as we can see here, if we start at D, then we go from D to B, and then from B to C, and then from C to A. So we end up at A. And no matter where we start, we always end up at A. So even if we start at like B instead, then we just go from B to C and then from C to A. So no matter where we start, we always end up at A. So A is the destination. And then here we only have 2, but we just output C because C is the only destination here. And basically the pattern here is that the destination city, first of all, is always going to be in the second index in the inner arrays, of course. But also there's no, like the destination city is never going to be in the first index in any of these inner arrays. So as we can see, A is the second element in this inner array, but we never see it in the first element, right? Like in any of these, it never appears here. And same with Sao Paulo, it's the last one here, but we never see it as the first one. Whereas like if we say New York or something, New York is also here, so that's not the final destination. So I think we're gonna want to keep track of all of our departure cities, because if it's not a departure city, then we're gonna know that it must be a destination. So to do that, departures, we're gonna want to add all of them into a set, and then that way we can loop through all of our paths and just see which one is not a departure, and that will be the destination city. So let's start by initializing our hash set, and we're gonna do string for each city. Okay, and then we're gonna want to loop through our paths and add all of the departure cities into our set. So this is going to loop through each inner array. So like this one, and then this one, and then this one in here. So for each inner array, basically, we're just going to add our path, but only the first one at index 0. So that's going to be all of our departures. And then once we've added all of those to our set, then we're going to want to loop through again through each path, and we're just going to see which one is not in our departures. So if our set does not contain this, like the second one, so like Sao Paulo or something. So I guess let me actually use this as an example so I can show you what I mean. And then our set would contain like London, New York, and Lima, right? So then when we loop through each of our paths, so we're going to loop through this one first, and then this one, and then this one. We're checking all of the index 1 of each one, and we're checking, okay, which one, like, does our set contain this, right? So like at index 1 here, New York, our set does contain New York, so we know it's not going to be a destination. And then our next one, right, we check Lima. Does our set contain Lima? It does. So then we know Lima's not the destination. And then we check Sao Paulo. And then does our set contain Sao Paulo? No, it does not. So we know that one is our destination. So we're going to check the index 1. And then if it doesn't contain that, then we're going to return that that city, right? So we would return Sao Paulo in this case. And then just so there's no error, because like there's no edge cases in this case since we know every single one has to have exactly 1. So we're always just going to return this, but just for the sake of not having an error in the text editor or whatever, we're just going to return an empty string at the end. So let's see. Okay. And then our time complexity is O of n, where n is the number of cities, right? So the number of, because here we need to loop through so we're looping through every single path here, and then every single path we have a city for each path, so the total number of like elements. And then the space complexity, and then we also loop through again here, but basically that's like O of 2n, which just simplifies to O of n. Our space complexity is also O of n, just because we add each city into the hash set. So technically it's like O of n minus 1, but we just simplify it to O of n because we need to store every single one except for the destination into our hash set. So that's also O of n. So that's it for this problem. Thank you guys for watching, and let me know what problem you want to see next. Thanks.